Welcome to the deep dive. Today we're unpacking something that might sound pretty technical, monoliths versus microservices.
Right.
But honestly, it's absolutely crucial if you want to understand how almost all the software we use, every single day is actually built.
Yeah. Things like your streaming service, your bank's app, even games on your phone. These ideas, they're sort of the architectural bedrock.
Exactly. And our mission today, it's really to cut through the jargon. We'll use some hopefully helpful analogies and just give you a real shortcut to being well-informed about what's actually going on under the hood of modern software. And you really won't need any coding knowledge. Just, bring your curiosity.
We've got a great guide for this, Monoliths versus Microservices, a beginner's guide. It's really designed to be accessible, breaks these ideas down without making your head spin.
Perfect. So let's start here. When you open an app or you visit a website, have you ever just stopped and wondered how all those different bits, logging in, searching, paying, how they're all put together?
It's a good question.
Well, at the core, there are really two kind of big ways to build software.
Yeah.
These monolithic and microservices architectures. Let's maybe tackle the first one. When we say monolith, what exactly are we talking about?
Right. So think of a monolith basically as one single giant unified software system. Everything it does, user login, showing products, handling payments, it's all built in this one large block of code.
One big block.
Yeah, imagine it like a huge Lego structure. All the parts are stuck together.
Right.
So if you need to change just one little piece, you might have to carefully adjust or sometimes even like rethink a big part of the whole structure just because everything's so connected.
That Lego analogy really works and makes it quite clear.
Yeah.
So can you give us a real-world picture? Like what kind of app would typically be a monolith?
Oh, sure. A classic example. Think about an early e-commerce website, maybe it's something from the 2000s.
Okay.
Everything, the product pages, the shopping cart, the user account, it all ran as basically one single program, one big self-contained thing.
Got it. So if the monolith is that giant all-in-one Lego piece, what about this other way we hear so much about microservices? How are they different?
Well, microservices take a completely different tack. Instead of one massive block, you break the application down into lots of small, independent services.
Just small services, okay.
Yeah, and each one handles a very specific job. So you might have one service just for payments, another just for user profiles, maybe a third for inventory. You get the idea.
Right.
It's kind of like, think of a fancy restaurant kitchen. With microservices, it's like having a team of specialist chefs. One chef nails the soup, another's the salad expert, a third does only desserts. They each work on their own thing, independently, but together it makes the whole meal.
That's a really helpful way to visualize it. And a real-world example, where do we see microservices?
Oh, Netflix is a huge example. They use microservices for, well, almost everything. You've got separate services doing the actual video streaming, others figuring out what shows to recommend to you, and completely separate ones handling the billing. Each part can be worked on, updated, managed on its own.
Interesting.
So the key thing to grasp, really, is that while both are ways to build software, they're really different in their structure, how you develop them, and crucially, how they scale up or down.
Okay, so that leads perfectly to the big question. Why choose one over the other? When does a monolith actually make sense? You mentioned simplicity earlier.
Exactly. Their main draw, especially at the start, is often simplicity. For smaller apps, maybe with fewer features, they're usually quicker to design, build, and test.
Because it's all in one place.
Right. Everything's one code base. It's just a term for all the code together.
Yeah.
So developers, especially on a small team, don't have to juggle lots of separate systems. They can streamline things.
And getting it out there for users, the deployment, is that easier too?
Generally, yes. Deployment tends to be more straightforward because you're just dealing with one application package, fewer moving parts to manage. So, yeah, monoliths often fit well for, say, small startups or simple apps where the team is small and the user base isn't huge yet.
That makes a lot of sense for getting started quickly. But then you have microservices. They seem to be everywhere now. What are their big selling points?
Well, microservices really excel in flexibility. Each service can be updated or maybe a bug fixed independently without messing up the whole application. And scalability is a huge one. With microservices, you can scale just the parts that need more power, like adding more chefs just to the soup station if soup's suddenly really popular, instead of hiring for the whole kitchen.
Right. So if, like, everyone's streaming videos at 8 p.m., you don't need to boost the power for the login system or the billing part at the same time?
Precisely. You put the resources exactly where they're needed, saves money, saves hassle, And then there's team independence.
How does that work?
You can have different teams working on different services at the same time. Each team sort of owns their service, their dish in the kitchen analogy. This speeds things up a lot because they're not constantly bumping into each other or waiting for another team.
Okay, with those advantages, flexibility, scaling, team speed, it almost sounds like microservices are just better, full stop. Is that right?
Well, not quite. They are often better for large, really complex applications. Think Amazon, Spotify, handling millions of users. But your question does hit on something important. If microservices are so flexible, why were monoliths the standard for so long? What problems did they run into that made people look for this new approach?
Yeah, this is where it gets really interesting, I think, because for a long time, like decades before microservices really took off, most software was built as a monolith. That was just the way it was done.
It was the default, yeah.
And the structure, like you said, all the features, search, payments, user stuff, all tightly knit together in one massive code base, often sharing the same database, the same servers, very interconnected. So if it was all in one big chunk, what was development actually like back then?
Well, you often had one team, maybe several teams, but all working on that single entire application. And the tricky part was, for almost any change, even a small one, a developer often needed to understand a lot about the whole system.
Not just their little piece.
Exactly, not just their piece. It's like trying to change one ingredient in a complex recipe. You kind of need to know how it affects everything else on the plate.
And the deployment, you touched on this, but fixing even a tiny bug on, say, the login page, what did that involve?
It involved redeploying the entire application, the whole thing.
Wow.
Which, as you can imagine, could take time. And every single time you did it, there was a risk. A risk of introducing some new bug somewhere totally unrelated, like fixing that Lego brick and accidentally knocking over a different tower.
That sounds incredibly stressful. And what about the scaling inefficiency? You mentioned one busy feature could drag everything else down.
Yes, that was a major issue. If just one part, maybe the product search, got slammed with traffic, you often had to scale up the whole application. Meaning adding more servers, more computing power to run the entire thing, even the parts that were just sitting there, not busy at all.
Yeah.
Which was, a huge waste of resources and money.
You can imagine, like, a bank website from the 90s, right?
Mm-hmm.
Probably one giant program doing accounts, transfers, customer info.
Definitely.
Making updates must have been slow, risky. If one thing went wrong, the whole online bank could go down.
Absolutely. So, yeah, to sum it up, monoliths worked, especially for smaller things early on, but as applications got bigger and way more complex, they clearly started to struggle. The cracks started to show.
Okay, so we've got this picture of monoliths kind of groaning under the pressure. Let's connect the dots directly. Problem number one, slow development because everyone's tangled in one code base. How do microservices fix that?
Right. Microservices enable faster development. Because each service is independent, teams can work simultaneously, in parallel, without tripping over each other. Fixes and new features for one service don't block progress on others.
Makes sense. Okay, problem two. Those scaling challenges, having to scale the whole costly app. Microservices solution.
That's the efficient scaling we talked about. Only scale the services that are actually busy. If video streaming is hot, scale that. If billing is quiet, leave it alone. You target the resources, saves money, much more efficient.
Got it. Problem three. Team conflicts and delays from large teams coordinating on one monolith.
Microservices bring team autonomy. Small teams own their specific services, they make decisions faster, they deploy faster, less coordination needed across the board. It speeds everything up.
Right, less bottlenecking. Problem four, those really risky updates where one bug could crash everything?
Yeah, microservices offer safer updates. A bug in one service, say the recommendations engine, usually won't take down payments or logins. It contains the blast radius, so to speak. The overall system is more resilient.
Okay, containing the damage. And finally, problem five. That technology lock-in, being stuck with old tools.
Microservices give you flexible technology. Each service can use the best language, the best database, the best tool for its specific job. You're not stuck using Java for everything just because the monolith started that way 20 years ago. You can innovate piece by piece.
That's a pretty compelling list of solutions, but as you always hear, there's no silver bullet, right? No solution is perfect. Every choice must have trade-offs.
Absolutely. It's crucial to understand both sides.
So let's dig into that, the full picture, pros and cons. Let's circle back to monoliths. What are the definite pros? We know, simplicity.
Yes, definitely easier to start, especially for small apps. Simpler to design, build, and test initially. And having that single code base means everything's in one place, which can be easier for a small team to get their heads around.
And deployment.
Simpler deployment, usually.
Yeah.
One application means one deployment process, fewer moving parts to orchestrate, at least at first.
Okay, sounds good for starting out, but where does the pain come in? The monolith cons.
Well, as it grows, it becomes hard to scale. Scaling one popular feature means scaling the whole costly app. Updates get foot. Slow and risky changes take longer, bugs can ripple through everything. And that limited flexibility we mentioned, you're often stuck with the initial technology choices, making it hard to innovate or adopt newer, better tools without a massive rewrite.
Right, the tech debt accumulates. Okay, now let's flip to microservices. We know the good stuff, but let's list the pros, clearly.
Top of the list is scalability. Scale only the parts you need. Huge advantage. Then faster development because teams work independently. And resilience of failure in one service doesn't necessarily break the whole app. The system can degrade gracefully, often.
Okay, scale, speed, safety. Sounds great. But what's the catch? Surely managing all those independent pieces isn't easy? What are the microservices cons?
You're absolutely right. The biggest one is complexity. Suddenly, instead of one thing, you're managing potentially dozens, even hundreds of services. That requires more planning, more sophisticated tooling for things like deployment, monitoring, and crucially, communication between the services.
Ah, so they need to talk to each other.
Exactly. And that introduces challenges. There's a higher initial effort involved in designing and setting up this distributed system correctly. It takes more time up front. And those coordination needs are real ensuring services can find each other reliably, handle network delays, maintain data consistency across different services. It adds a whole new layer of problems to solve.
So it's definitely not free flexibility.
Not at all. What's really fascinating here is it's not about one being definitively better. It's much more about suitability. It depends entirely on the specific needs. Context is everything.
Exactly. Like, think about a small personal blog. It probably uses a monolith, right?
Almost certainly.
It's simple, it's cheap to run, it just doesn't need the complexity of microservices. But then you look at something massive like Uber.
Right. Millions of users.
Yeah.
Real-time ride matching, payments, maps, driver tracking.
That screams microservices, doesn't it? Separate services for each of those complex functions, scaling independently.
Precisely. It's the only way they could manage that scale and complexity effectively.
So, wrapping up our deep dive today, I think the key takeaway for everyone listening is pretty clear. Monoliths. They're great, really effective for smaller, simpler applications. They offer ease of development, straightforward deployment, especially early on.
They have their place.
But microservices, they really come into their own for the large, complex systems that need that flexibility, that massive scale, and the ability for lots of teams to innovate quickly and independently.
Yeah, the choice always boils down to the application's specific needs, how much you expect it to grow, and, frankly, the resources and expertise of the team building it.
Understanding these basic architectural choices, monolith or microservices, it's just super valuable if you're curious about how all these digital services we rely on are actually put together.
It really is. It gives you a new appreciation for the engineering complexity that's humming along behind the scenes of the apps you use every single day.
Yeah.
And maybe why some feel more reliable or update more often than others.
Definitely. And maybe here's a final thought for you to chew on. Given that this choice hinges so much on things like size, complexity, growth plans, team skills, how does a company know when it's actually time to rethink its initial choice? Like, when does a monolith become too painful? Or maybe even, how does a company know if staying with a monolith is still the right call for its specific niche, even as things change?
That's the ongoing challenge, isn't it? Knowing when, or even if, to make that big shift.